Right, hello again everybody, welcome back. In this video I'm going to go through the answers to the convex lens ray diagrams questions that I set in the previous video. If you're watching these out of order, then I suggest you go back and watch the previous video, please. Convex lens ray diagrams 1. I think it's important to see the questions before you see the answers. Above my head you see the basic rules for drawing a lens diagram for a converging lens or a convex lens. Here you've got an object. I should point out that rays of light will be going off in all directions from this object, but we only need two rays to be able to locate the image. And the two rays we look at are the one that goes straight through the centre of the lens and carries on in a straight line, and the ray of light that is parallel to the principal axis, hits the lens and refracts through the focal point. Again, any questions about that? I think I've answered them in the first video, so please go back to that. Okay, so here's the basic diagram again that we looked at in the previous video. When you draw a lens diagram, the first thing you draw is the principal axis, which is a horizontal line. The lens is located at 90 degrees to the principal axis. You put a straight line through the centre of the lens and you assume that any rays that you draw are refracted at that central line. And as I said already, one ray will go through the centre and one ray will refract. A parallel ray will refract through the focal point. In Cambridge questions, they're likely to ask you to draw a diagram and they'll tell you to scale how big you should draw your axis, how big you should draw your lens, and how far away from the lens your focal point should be. Okay, so let's go through the answers quickly. The first question I set, and I'll just go through it again, was for an object further away than F, but not as far as 2F. So we've located the object there. My first ray of light, as I said, goes through the centre. The second ray of light is parallel to the principal axis and hits the lens in the centre and then is refracted through the focal point, and the image is formed, or the top of the image I should say, is formed where those two rays meet. We draw the image and we know a few things about this image. Number one, we know the image is real because the rays of light are being focused to a point, so therefore we can put the image on a screen. It's upside down or inverted compared to the object, and it's magnified because the red arrow you see here, the image, is bigger than the black arrow that I showed for the object. I could have asked you to calculate the magnification. The easiest way to do that would be magnification equals image size or image length divided by object length. It's the ratio of the object size, the ratio of the image size compared to the object size. Okay. Question 2 I asked you to look at was for an object placed directly at 2 times the focal length. If my focal length is 5 centimeters, 2f or 2 times the focal length will be, on my diagram, 10 centimeters. First ray goes through the center of the lens. The second ray is parallel to the principal axis and hits the lens, is refracted through the focal point. There's my object, and if we've drawn it correctly, there's my image. If we've drawn it correctly, the image should also be at 2f, and the size of this image should be the same size as the object. So therefore, for this question, we can say, again, it's a real image because the rays are being focused together. The image is upside down. We can see the image compared to the object. The image should be, if we've drawn it correctly, the same size as the object. And if we've drawn it really well to scale, the image should actually be located at 2f on the other side of the lens. We know that, by the way, because if the image is the same size as the object, this distance, the image distance should be the same as the object distance. I'm not sure if I did a 100% great job of drawing that to scale there. Maybe I didn't quite get the focal length in the right positions. Okay, the next question. I asked you to locate the object at the focal point, F. I know some of you worked this out when we talked about it in the classroom. There's a trick to this question. Our first ray of light goes through the centre of the lens, and the second through the focal point, and these rays of light emerging from the lens are actually parallel. So there's no way that they can converge. So therefore, in this case, for an object at the focal point, there is no image. An image can't be formed. Okay, and the final question, for an object very close to the lens, in fact closer than the focal point, we do the same again. One ray goes through the center and the parallel ray goes through F. Now you might think something's gone wrong here. It's a converging lens, but the rays are not converging. But let's give it a bit of thought. The rays are not converging, but we can follow the rays backwards. We do that with a dotted line. And if we follow them backwards, they seem to converge at this point. We can put a dotted arrow there, and the dotted arrow represents a virtual image. It's not a real image, but the rays seen by the eye seem to be converging at that point. That's my attempt to draw an eyeball attached to my brain. The eye gathers the light, and the brain thinks the light is converging at that point, so the brain puts together an image where it thinks the rays of light are coming from. Now in this case, the image is not real. The image is virtual. We can't put it onto a screen, but an image does exist, but it only exists in your brain. It's not a real image, it's a virtual image. That virtual image is, well in this case, it's not upside down. It's upright, the same side up as the object. And we can see that it's bigger, the image is bigger than the object, even though it's virtual, so therefore the image is magnified. What I've shown you there is exactly what happens when you look through a magnifying glass. The image you see in a magnifying glass can't be put onto a screen. It exists in your brain. It's the same way up as the object you're looking at, and it's magnified. It's a virtual image. Okay, I went through that very quickly, but I think the good thing about YouTube is you can stop each one and pause and take a look at it, and make sure that your diagrams, I think I did a reasonable job of trying to draw these on PowerPoint. Make sure your scale diagram should be better than mine, but they look like mine, and you basically should get the images in the same place with the same characteristics. Okay, I hope that was helpful. Very quick video clip. Any questions, please let me know. Okay, take care everybody, and I will see you in our classroom.